Okay, consider this graph here. Okay, it's an x cubed graph. Where are the critical points? Okay, what do we also notice about them? Well, let's see. Critical points. I see a critical point right here, a minimum, a relative minimum, then swings back up, and here's a relative maximum. Also, it's curving up, and then right here it starts curving back the other way. Right there's a point of inflection. So we have a minimum, maximum, and a point of inflection where it starts turning back the other way. Now, what do we notice about them? Well, here's what I notice that's key right here, okay, as far as the minimum and the maximum goes. Notice if we draw the tangent line, it's a perfect what on both those. At the maximum minimum, it's the perfect what? Horizontal. It's a perfect horizontal line. Now, if it's horizontal, what does that mean the slope has to be? Well, this is critical. The slope is going to be 0 there. So we can actually find our minimum and maximum points by knowing that the tangent line will have a slope of 0. So we know the minimum and maximum points occur when the tangent line has a slope of 0. Now, how's that going to help us? Well, here's how it's going to help us. We'll be able to find the derivative. What does the derivative tell us? Well, let's see. Well, we can find the derivative of this guy. So let's find the minimum maximum of him. How are we going to do it? Well, let me think. The derivative is 3x squared plus 12x. What does that do? That tells me the slope at any point. That tells me slope at any point. How's that help me? Well, think. This line's going like this. This equation tells me the slope at any point. Well, the key is I want to know what x value I'm going to plug in there that's going to give me a slope of 0. That's going to occur twice. So what I want to do is I want to say, hey, when does this guy have an answer of 0? When is his answer 0? So if we solve that, we can find it. Well, okay, what factors out here? Let's just solve it for x. That'll tell us where this and this points happen to be. Well, start off, I'll factor out a 3x, leaves me behind with x plus 4 equals 0. So either 3x is 0 or x plus 4 is 0. Well, divide by 3, so x is 0, or my other option, negative 4. That means if you plug 0 into this equation, you're going to get a slope of 0. If you plug negative 4 into this equation, you're going to get a slope of 0. That tells us that it occurs when x is negative 4 and when x is 0. Knowing that the line looks like this, that means, hey, that right there is 0 whatever, and then right here is negative 4 whatever. So we know the x values. Now, how do we find the whatevers? Well, this is just a line right here, and you're just saying, hey, when x is 0, just plug 0 back into the original equation to figure out what f of x is or what the y value is. So we'll plug 0 in and we'll plug negative 4 into the original equation. If you plug them into the derivative, it's going to give you an answer of 0 because the derivative is telling you the slope, and we were looking for when was the slope 0. So we plug 0 into this equation, we're going to get 1, okay? 0 cubed plus 6 times 0 squared plus 1 is 1. Negative 4, a little trickier. That'll be negative 64 plus negative 4 squared, 16 plus that, then 96 plus 1. So 97, take away 64, 97, take away our 64, gives me 33 for that height there. And you can see it's at a height of 33, which is way higher than this height of 1. So we know we're correct with this being our maximum and that being our relative minimum. Now, what about the point of inflection? How do we find that? Well, it's sort of the same idea. What you're going to do, it's not based off of the first derivative, but the second derivative. So let's see. First derivative, 3x squared plus 6x plus 5. The second derivative, 6x plus 6. And then we simply set that equal to 0. We solve 6x equals negative 6. a point of inflection is going to occur on this one at -1. Well, how do I find the y value? Well, you just plug -1 into the original equation. So f of -1. So we'll do -1 cubed plus 3 times -1 squared plus 5 times -1 plus 2. That gives us what? -1 here plus 3 plus -5 plus 2. So that's 2 plus 2, 4, minus 1, -1. Funny enough. But the point of inflection occurs at -1 comma, y value being, we just found it to be -1.